We're going now. Okay. Okay. So now everybody can see you and me. Okay. Great stuff. Welcome everyone. This is CityJS TV. We're coming straight after this. This is the first one we're doing after like a long time. The last series of those kind of virtual talks, we have been doing them during pandemic. And I'm Aris. I'm a CityJS founder and organizer of JS Monthly. Um, and we're coming here today with a first um, CityJS TV talk with these two amazing ladies. So without further ado, I'm going to introduce you to her. So who would like to introduce first?
I'm happy to get started. So yeah, I'm Khadija. I'm happy to be here. And my background in software engineering. I'm currently a founding engineer at Vouchsafe. And yeah, I think there's so much going on right now, and it's just really fun exploring like new technologies in our free time as well, and seeing what we can build. So yeah, we have some interesting things in store.
Yeah, and I'm Nkechi. I'm also a software engineer, currently a founding engineer at Vouchsafe. What else? I mean, in my free time, among other things, I like to code. So this has been a really interesting season so far, like learning about agents and like building with them. So we're happy to be here and talk about what we've built.
And you said before that you are playing tennis as well.
I
So
I
yeah.
love this. That's my obsession right now.
So it sounds like you're two people that you like to be very active. You try to find new things, and this is where we are here. That's why I like to bring people up that they're very active. They want to learn new things, and they bring the stuff when they're really hot. They're like on fire.
Yeah.
And at this point of time, agents and AI, it's something really, really big. So I believe that it's amazing that I found you during the meetup, and I know you came before to a meetup before that, and I was really happy to see that people coming up, they do their talks, and the talk was amazing. So I thought of doing this talk again, but in a shorter kind of version, because we're planning to do something bigger, like a workshop. So what we're doing today, it's like more like a taster event where you can see a bit about it and you can find out what you're gonna watch during the workshop. So yeah, if you would like to share your screen and we can go forward from that.
Yeah, that sounds good. So let me share this. Can you see my screen okay?
I can see your screen. Yep.
Okay, perfect. Thanks for the introduction and thanks everyone for being here. So yeah, as Iris was saying, I'm Khadija and this is my colleague
Nkechi.
Nkechi. And basically, a few months ago, we got interested in AI agents and we decided we wanted to just do a hackathon, build with it, explore it. And we decided to focus on the travel space. It seemed like an interesting problem space to explore. And last week, we gave a talk on this topic, some of the things that we've learned, some of the practices. And yeah, CityJS decided that this would be a good opportunity to share some of that. So we'll go through some of the concepts today. And in case you'll be going through some of the theory, and I'll be giving some of the code demos as well. So on to you.
Yeah, fantastic. So the goals of this session are to give you a sense of what an agent is, to show you the core pieces that turn an LLM into an agent, plus a quick demo, and to get you excited about building a crew of agents, just like we were. If you have any questions throughout, drop them in the chat. So what even is an agent? An agent broadly is a system that takes a requirement, decides the steps to achieve it, and executes them autonomously. More specifically, an AI agent is a system containing an LLM that understands a goal, decides how to achieve it, and acts on its own. To explain this better, let's look at the difference between a regular LLM and an agentic system, also known as an agent. On its own, an LLM is just an intelligence layer. It's smart, but it's static. It just gives information. Underneath all the bells and whistles of chatbots like ChatGPT, Simple LLMs are what you have. They're simple LLMs just predicting and generating text. Agents are more dynamic. They have the ability to think, decide, act on their decisions, remember what they've done, and iterate, all towards accomplishing a task. So you could ask an LLM to plan a trip for you, and while it could think and give you a reasonable plan based on its internal knowledge, it wouldn't actually be able to, A, make that plan a reality, like by booking flights on British Airways, or B, make that plan be based on current reality, like by using the latest info on attractions. If you were to ask an agent this same question, it would be able to give you a reasonable plan and execute on this plan. This could involve searching for the latest attractions in an area, getting transportation plans, and emailing you the completed itinerary. So that's the difference between a simple LLM and an agent. One is giving you information, and the other one is getting you results. So how do we go from an LLM to an agent? For that, we have the agentic equation. At its core, an agent is a function running in a loop containing an LLM plus tools plus context of what it's done, which gives you $1 million startup or an agent, however you'd like to call it. We love that joke. We love that joke. Essentially, an agentic AI workflow has an LLM looking at the context, deciding what step to take to achieve a particular goal, calling the tool it thinks will achieve that step, and then updating the context with the result of the tool call, which gives it a level of self-awareness about its actions, and a loop to start it all over again till the LLM thinks the goal has been achieved. So this loop, look, decide, act using tools, update context, is the workflow of an agentic system. It's also quite similar to how we work. We also work in increments, use tools, and make internal judgments ourselves to see if we consider a particular task done. Now let's look at two major components taking an LLM to an agent. Tools. So on its own, our LLM is just a brain. It can think, but it can't act. We give it tools, which is the equivalent of hands and feet, so it can take action. They're the APIs or functions it can call to achieve an outcome. So if it needs to book a hotel, it calls the booking tool. If it needs flight info, it calls a flights API. Even other agents can be tools. Conceptually, you can think of this as delegating some of your work to someone else who can decide how best to complete it. You just expect the result of what they do in a particular format. So I'll hand over to Khadija to show us how it is when we give an LLM access to tools.
Thank you. So let's take this scenario. Find me activities to do in this area. We'll just take Manchester for this example. We can ask the LLM to do this, and it would do a pretty good job. It found some hidden gems in the Northern Quarter, the John Rylands Library, but it's just using its internal knowledge for this. It can't actually fetch for live, real-time information. But what if we gave it the ability to search the web? Now it can actually take things to a next level. So the way we do this is, the way we typically do it is through writing functions as a starting point. So in any SaaS app, you would just start writing the function. So in this situation, we have a search Google function and search Google events. So under the hood, it uses SERP API, which is a really good API to use, I'd recommend. And basically, it takes in a structured input, so a query and a maximum results, and then it returns an array of the Google search results, so the title, the date, etc. But how do you take this and give it to the LLM to use? Because it's quite a structured way, and the LLM is notoriously known for having a lot of natural language. The way we can do this, well, one of the ways is through function declarations. So each LLM provider has their own approach, but for this demo, we'll just go through Gemini because they're free. And the way we could do this is we write this, it's almost like a contract of what tools they can use and how they can use it. So here, it knows that it can use search Google events. It knows the purpose is to search the internet, and it needs to pass it these arguments in this way. So a query is a string and the maximum results. and this is the required field. So now the LLM knows it has this tool at its disposal and how to call it. So how do we then give this to the LLM? So the way we could do this is, let me remove that auto completion, is passing it as the tools. So here we've initialized a Gemini client, and we've given it this role, an activities planner. We want this LLM to search the web for current real-time activities. And now it has the ability to search Google. So when we actually run it, it returns a response. It says what functions it wants to call. And if it wants to call search Google events, then we actually execute it and pass in the arguments that it put together. And then we pass those results back to the conversation, back to the context window. So on the second call, it has the initial goal, which is to find activities. It has the Google search results, and now it can use that to form its final answer. And this is where the agency comes in, because it doesn't always decide to call this tool. We haven't explicitly told it to do so. So if it doesn't, then we might need to tweak the prompts a little bit. So now we've created the tool, we've passed it to the LLM. Let's go back to the request and ask it again. Find me activities in Manchester for this weekend. So if we run it, I'll just go back to the terminal, and we can see that it actually wants to call the function, which is good, thankfully, because I don't have the patience to tweak the prompts again. And now we can see that it has the results. It has real-time events for this weekend. So there's R&B brunch. There are, I don't know what this is, like a palace theater. But you can see now how we've just extended this LLM to interact with the world. Now it can search Google. It could search the weather and come up with ideas. This is basically taking it a step further to actually being a agentic system. So yeah, that's it for the demo, and I'll pass back to you.
Nice. So if tools are the agent's hands and feet, then context is its working memory. Context is all the relevant information the agent needs to achieve its goal. This includes the goal itself, the steps already taken, and any other information needed to achieve its task. It acts as a form of memory. Without it, the agent forgets what it just did, what it's trying to do, and how it can achieve it. You have two sources of context. You've got internal session-based context and external persistent context. Session-based context is gotten from the prompts and tools you give an agent access to while it runs. Unless this is saved somewhere, it goes away after the session is over. Just like that perfect conversation you got with ChatGPT that you're dreading when it ends. This context is where we can easily track which steps in the workflow have been completed. It's also how the agent knows it has already booked the flight, so it should go on to finding a hotel next. It also contains the prompt which tells the agent which personality it has and the goal it's trying to achieve, like telling ChatGPT that it's a trip researcher looking for activities in a particular location, just like Khadija just did. Persistent context is information pulled in from different external sources, like a vector database. For example, we could permanently store a user's travel preferences in a vector database that the agent will reference as additional context when planning an itinerary. So I'll hand over to Khadija to show what this looks like in an application.
Nice. Thank you. So if we go back to this scenario, we gave the LLM access to search the web, and we took it a step further. But what if the LLM can now access this long-term memory about the user's preferences, like what they enjoy, what they don't enjoy? Then it can actually have even more specific results. So there's different ways that you can actually do this. And one interesting way is through vector embeddings. There's a diagram that I actually quite like, so I'm going to use this to go through like a typical workflow. So let's say we take in some content about the user's preferences. Maybe they like did a feedback recording. What we can do is we can then embed everything that they say using an embedding model like Gemini, Cohere. And that will then create vector embeddings, which is just numerical way of storing the meaning of words. So instead of having to use keyword search, you can just use semantic search instead. Then you'd store that into the vector database, and now you have that available as long-term memory. During runtime, if you want to fetch information from the database, the LLM or the application can then ask the question like, what's their favorite food? Then that question would be embedded using the same embedding settings and model, and that would then be used to fetch for the information. So now, instead of having to search in extremely structured ways, you can literally ask the information. And I'll just show an example of one that I set up earlier. So in this situation, I took in some feedback about the user's experience. They liked cafes, walks in the park, they preferred vegetarian food. What we did is, if I go to the code, we took that just array of strings, and we used, I don't know why that's in the way, Gemini's embedding content. Cohere is quite good, but this time I used Gemini. And then we just stored it into the index that I created. This index looks like this. So in Pinecone, I created this user preferences index, and inside you could see that we have all of this information stored. So this person, as I said, loves cafes, cozy jazz bars, they like cheese. I don't know where they got that one from. And it's stored in a way like this. So now, if the LLM asks what's their favorite food, they don't have to search for those specific words. It can actually see that love is similar to like, cheese is a type of food, and then it would say, this is relevant, let's bring that in. So that's how we approach it. So let's actually see how we give the LLM that ability to do that. So the way we do that is, let's go back to the code, by creating another tool. So what we've done now is we've created a new function called search user preferences. This function takes in the query and we'd embed it, and then we just search that index as well for the top results. To actually provide this tool to the LLM, we've created the function declaration. So this time it knows if it wants to search for the user preferences, this is the tool to use, and it needs to form the arguments in this way. So an example query could be, what type of food does the user like, or their restaurant preferences? And then finally, we've extended this LLM. So now it's a personalized activities planner, and it must follow these steps. So first, we asked it to search the user preferences to understand their tastes. And then it should make 2 or 3 specific web searches. So maybe the type of vibe that they like, the specific time of day, any like venues. And in this way, instead of just searching events in the area, it's more specific. So we added this tool here. And this time it's a loop because there's obviously a few extra steps like searching their preferences, making two or three web searches, and then looking at those results until it gets to the goal. And this is very, very familiar to before. So if we see that it wants to search the user preferences, we call this function and we push the results, and then finally we'll get the result. We'll get the response. So let's actually run this and see if it does the task. So I'll go back to the terminal and we can see that it got the request. It's searched the user preferences, which is good. And based on that, it found that it liked cafes, parks, vegetarian food. So it's done specific searches for that. And finally, based on those results, it suggested some interesting places. So Fuel Cafe Bar, that's a vegetarian or vegan restaurant in Manchester, walking trails, and more specific targeted results. So now we've provided the LLM with a tool. We've provided access to long-term memory. So now it's so much closer to being a more agentic system. So yeah, that's another example of how we can extend the LLM to being an agent. And I'll hand it back to you for the multi-agents.
Let's just go back here. Okay. So far, we've seen one agent working on a single task using multiple tools. That might be enough for some use cases, but for bigger objectives, you often have multiple steps that might benefit from separation of concerns. Just like how in manufacturing, you have when the Japanese companies pioneered the assembly line to make processes more efficient. Multi-agent systems work the same way. Multiple agents collaborate, each focusing on a part of the larger workflow. This makes them especially useful for complex workflows with well-defined steps or iterative processes that need to loop back and refine. So what happens when you have multiple agents working together? You start asking, how do we coordinate them and make sure they're aligned towards the same goal? The answer is quite intuitive. You simply break the big goal into smaller specialized steps for specialized agents, and you design how those agents pass their work to one another. This is the basis of building a multi-agent workflow. Now, if you were part of the talk we gave last week, then you would have seen us go into more detail about building this sort of workflow. We spoke about different ways to organize a multi-agent workflow based on the type of problem you're solving, such as having a sequential workflow where each agent completes its work and passes it on to the next, like an assembly line, or a more hierarchical workflow where you could have an orchestrator agent that's calling different agents to do part of a job, and that lends itself well to more iterative workflows. We also gave another demo showing how we used these principles to coordinate multiple agents to plan an itinerary using a 3-step sequential workflow. So we don't have as much time in this session to go into this much detail, but that's why we're setting up a workshop for you to come and build with us and learn these principles intuitively. During this workshop, we'll build upon the principles we've already shown you with one agent and move on to additional topics that can help you build resilient multi-agent systems, such as workflow management. So this goes into how you coordinate your agents to achieve a particular task. And it could include things like having an orchestrator agent to coordinate multiple agents and complex tasks. We could go into model agnostic architecture. This way you can build your framework to be agnostic of the LLM provider. So you can, let's say, swap your voice transcription service to use maybe DeepGram over OpenAI's Whisper model without changing the way your code actually works. You would just design your framework to be LLM agnostic. You could also include guardrails and validation. So this is taking us from the more MVP, playing around building models to the more production-ready and resilient systems. Guardrails help ensure that the input and output of every LLM call adheres to a certain standard, and it helps us prevent the undesirable effects that could come from working with LLMs that are non-deterministic in applications where we need them to be reliable all the time. And finally, we'll also go into evals. This is where we can run regression tests to measure our agent's performance. We can fine-tune our prompts and make sure that any changes we're making are not causing regressions to the actual output. So yeah, we're currently confirming dates for October. So if you join our waitlist, you will be the first to know once it's out and you'll get an early bird discount code. It's going to be a paid workshop with snacks and drinks included, and you will leave with both an intuitive understanding of agents, multi-agent systems as well, and you also have a working system that you can extend for your own use case. So, I mean, that's a wrap. That's a wrap. That's it.
That was really good. I mean, it leaves the people, it's not, like those kind of series where you're watching the series and then you throw up the adverts when you are about to see like what's next. Like that moment, like very crucial moment. But yeah, this was like I said in the beginning, like a teaser, so it's not like the full product, let's say.
Yeah.
So it was a nice. You get a nice idea of what LLMs can do, how you can work with them, because like you mentioned, testing as well, and a lot of this. So, so how long have you been working with LLMs, and and in this kind of those kind of things? Like how long have you been working with those?
For me, it's quite recent. I'd say like in the past few months, maybe up to a year. It was like a slow, gradual interest into it. So I think at the beginning, it was just as a developer, you just generate some code
What
and
was
AI change
the
it. But to actually build with it, I think there were like certain use cases that we wanted to solve for, particularly like parsing documents and like really unstructured images of things. And then since then, every time we came across an issue, we just learn a new approach. Like, okay, how do you make sure that what you're releasing is, I don't know, stable? What kind of testing have you done on it, guardrails, etc. So I think it's just like a slow, progressive learning and interest into it.
learning curve? This we're entering a new world, and the I don't know, like in some cases, I mean, this is artificial. There is like I'm gonna be doing a talk in Alicante in about a month. In some ways, what they call AI is not artificial, it's more automated because there are some tools that they automate stuff that we don't want to do. But LLMs, they do the actual artificial work, they just go grab data, they analyze it, and then bring back to us, what it matters, the most. So, and it's very, how to say, powerful. But all these kind of tools that we have to use, they're like new. So it's not, if maybe a year ago we're still doing CSS, some really JavaScript stuff, setting up single page applications. Now it looks like we're entering a new world where you have to work with tools that do a lot of data analysis or manipulation of data on the fly. Right? Is that correct?
I think things are changing quite like quickly in terms of like the technology we're using and how the technology allows us to move faster to build things that maybe one person might not have been able to build in a short amount of time and to do more things. I think this is where the concept of having like guardrails and ways to ensure that the information, the solutions we're getting from these new tools, they they are reliable, they're not causing any adverse effects. So I mean, that's why with like when we started building, I mean, on my side, I had been playing around with like agents and building agentic systems and integrating LLMs into tools I had been building. And at a point I realized, oh, sometimes it gives a response that throws off the entire app. Like this, you're supposed to give a response in this particular shape, but it doesn't. So then you start thinking about how do you actually make this a production ready system? What are the things we add to these helpful tools, to these LLMs to make it something more predictable, especially since traditional software should be reliable. So yeah, that's what I'd say.
So you found in the beginning that it was not giving you what you're expecting, right?
I found actually that it's a lot to do with the prompting and use
Yeah.
case, right? Like I started learning to code when ChatGPT came out, and I used that to form a mental model for software engineering and computer science concepts. So if I didn't understand something, I would say, explain it intuitively, give me an analogy. I think it's all in the way you use it, and the more you use it, the more you start to know this question I'm asking Claude, it will waste my time. I should do it myself. So you start to actually learn, okay, this is how I should work with it. This is the model that's best for this. I think it takes practice, but I won't say it's perfect now. I just think it's really good. But by using it, you get to enjoy the actual benefits of it.
That's very good. That's very good. Yeah, I mean it's the what they call the prompt engineering. That's what you're referring to, right?
Yeah, like you see a lot of people solving for problems that are happening right now. For example, if we wanted to produce like a JSON response and we can pass it downstream in the system, I think there was a new approach that a company called like BAML tried to put out. So it's like, okay, what are the things that you can do after the LLM has responded to clean the data, make sure that it fits to the schema that you want.
Mhm.
Then there's like MCP protocols as well, if
Yes.
yeah, that's emerged because there's all of these providers, and how do you um have like a single standard way of building these systems? Yeah, and then there's like, okay, the model might change its quality over time. So how do you do like uh almost like regression tests to make sure that,
Okay, yes.
yeah,
This is
the
the
like
stuff that you're gonna do in the workshop, basically. So how you can ensure that you're building with one tool, how to ensure that the data that you get out is correct. Nothing has changed
Mhm.
because models are like there was ChatGPT 4 and then it came. Is it now? What is the version now?
Five?
Five? Is it five?
Right?
I
Yeah.
think it's five. The one that does everything.
Yes. So the from 4 to 5, maybe you are building something, but there have been changes. So
Yeah.
to be able to test your code against those kind of changes. So you don't come out of the blue and say, "Oh, why is not working now? I thought this was I fixed this one, but it's not you, it's another system, right?"
Yeah.
So
I think
in-
that's interesting now because to my knowledge, these are recent problems. Like
Mhm.
maybe to an extent you could have, if you relied on an API that somebody else worked on, you would know that there's a breaking change or something would happen and that feature wouldn't work.
No,
But
makes sense.
for the first time now that I'm aware of, it seems that models can change and suddenly what you built doesn't work.
Yeah.
Right. So I think we're learning now how to, that's why guardrails are such an important thing. And like building systems around, it's not just the LLM in isolation. It's not just the agent in isolation. It's the entire system that you use to develop and produce a working, reliable system.
But you're using more than one tool. You're using Gartles, you're using another website that is storing the searches. What was that one?
Oh, the vector embeddings. Is that
Yeah,
what you're
so
talking? Yeah, so like I think like RAG was like the popular thing for a while, and it's like, how do you store like a knowledge base of like a company handbook or documentation, and then the LLM can retrieve that and provide information to the person. And then after that, like I think MCPs came and took over the conversation. And it'll just keep happening because it's quite an emerging field. But yeah, I think the thing that just interests me, the thing that impresses me the most, um, is I think before everything was very structured, like keyword searches, like all the designs had to be uh made so that you can get specific inputs. Like a lot of startups are basically like form builders, and then you take in inputs, you process it, you get a result. But this now takes it to another level by taking in like natural language, and then you can do stuff with that. Um, so I think that step forward is the thing that I find most cool.
Yeah.
there's gonna be more. I mean, I don't know what's gonna happen in the next 2 or 3 years or even more. Like, I don't wanna think, but it's moving very fast.
Yeah.
So I
Yeah.
think people that watching us, they have to move very fast because they have to join our waiting list. So you can see that QR code.
Yeah.
Uh, I like you that you're very proactive, and I really appreciate it. So yeah, join that waiting list. We're gonna let you know when in October we're gonna run this workshop. It might, I mean, I don't know because I'm also starting learning a lot of these kind of things, but I come more from the UI point of view. So I've been working a lot with Figma and MCPs,
Mm.
and I want to learn more of this. So, I mean, this is how I started teaching and also doing the meetups because I wanted to learn. So, a lot of times when you want to learn something, when you don't have a job or something, the best way to do about it is to learn and then teach it to other people. This is the best approach. So, I'm so glad that you came across and you volunteered to do the talk, and I think it opened up more opportunities, let's say. So yeah, we will have another opportunity to do this in more extensive way. So we will let you know. Probably, I think it will be best to do it around the end of October. But I'll be in touch with the. So you also have a waiting list. So the people that watch it later, this live streaming, they can scan that QR code. They can sign up with our waiting list, and you're gonna get like a small discount because you're gonna be the first ones to join us. So yeah, thank you, Khadija, and sorry, the other name it's hard to pronounce. Let, how do you say your name? The other one?
Nkechi.
Nkechi.
KG. I need to go to Lagos. I did I did tell my friends in Lagos about you people because
Really?
we did also a conference in Lagos, Nigeria.
Ooh.
I did two of them. So I
Oh,
did tell them I have some really good people here with me. So I did tell my people there. So yeah, we will be in touch and we will talk a bit about how we're gonna do the workshop. And until then, the people have to scan the QR code. So I'm gonna end the stream now, but you stay here. Okay, that was good. That was very good. Sorry, it was the first one I was doing.
yay!
Uh,